On October 16, 2025, the quiet order of astronomy broke. A single image appeared on the astronomer's telegram. It came from a modest telescope in the Canary Islands and showed something that seemed to mock the laws of motion and light. At the center of the frame was the interstellar object known as 3I Atlas. Around it, the familiar haze of a comet's coma. But stretching from that glow was a narrow plume 6,000 kilometers long, pointing straight into the sun. Every instinct in a physicist's body said the same thing. That cannot happen. For centuries, comets have obeyed the solar wind. Their tails always stream away from the sun. The sunlight pushes dust and gas outward like a steady breeze. 3I Atlas defied it. Scientists across observatories paused what they were doing. They refreshed data links. They checked calibration logs. They asked the same question. Is the image fake? Is this an artifact of processing? Or has nature presented something entirely new? If these mysteries pull at you the way they pull at me, don't stay on the sidelines. Tap like and subscribe so you'll hear for every twist as this story unfolds live before us. Follow the evidence with us. This channel exists for those who can't look away when the universe shows a contradiction. Like the video. Share it. Tell us where you are watching from, what time it is there, and whether you believe we're being shown the full truth or only the safe version. Your curiosity funds the search. Your attention keeps the light on in the lab. The data behind the image came from observations on August 2nd and 3rd. The telescope had been following Atlas for months as it curved through the inner solar system. When researchers enhanced the images using Laplacian filtering, a faint line appeared. It was not noise. It was coherent, directional, alive. They compared exposures from separate nights. The line moved with the object. It was not a background star trail or cosmic ray streak. It was part of Atlas itself. At first, the team assumed a software error. They reprocessed the raw frames. They used different algorithms. The feature remained. Then they asked for independent confirmation. Within days, other observatories reported the same thing. From Chile, from Hawaii, from Spain, different instruments, same result. A jet aimed toward the sun. The community turned cautious but intrigued. Some argued the plume might be a faint dust lane illuminated by geometry. Others said it was an artifact created by stacking images of a rotating nucleus. But spectroscopy ended the debate. Light from the plume contained the same molecular lines as the coma. It was real material, emitting real photons, moving in the wrong direction. To understand why this was impossible, remember the basic rule. A comet's activity comes from sunlight heating frozen gases. The gases expand and escape, dragging dust with them. Solar radiation pressure and the solar wind then push that dust away from the sun. Everything about the physics is outward. The only way to get a jet pointing inward is to reverse the pressure gradient itself. 3I Atlas behaved as though some internal engine were pushing material against the wind. Astronomy depends on patterns. Comets have been catalogued for centuries, and every one of them obeys predictable thermodynamics. Outgassing starts when sunlight reaches a threshold temperature. Jets form on the sunlit side, tails extend outward, brightness follows distance. Atlas broke all three expectations. At conferences, researchers spoke of it as the uphill waterfall. One described it as seeing smoke flow into fire. The phrase stuck. Atlas was the first waterfall that ran uphill. If the feature were real, either radiation pressure didn't behave as expected, or some new force was at play. Both options were unsettling. So the first task was to remove doubt. Teams pulled the raw detector data. They corrected for trailing stars, for cosmic ray hits, for atmospheric distortion. They examined unfiltered frames looking for the structure before any enhancement. There it was, faint but visible, aligned perfectly with the Sun. Then came independent verification from the Hubble Space Telescope. Hubble saw the same asymmetric glow. The European Southern Observatory confirmed it again from the ground. When multiple instruments using different optics see the same thing, the odds of error collapse. The verdict became clear. 3I Atlas was emitting a 6,000-kilometer plume directly toward the Sun. Once the geometry was certain, attention shifted to chemistry. Spectra from Chile's Very Large Telescope contained lines that shouted an element astronomers rarely see in gas phase, nickel. Normally, when nickel appears in a comet, iron appears with it, and iron is stronger. Here, the situation reversed. Nickel dominated, iron nearly vanished. This ratio made no sense. Every stellar process known to science produces more iron than nickel. Meteorites show the same pattern. Planetary crusts do too. To get nickel without iron, something selective must have removed the iron or created nickel in isolation. At the same time, data from the James Webb Space Telescope revealed another shock. Carbon dioxide outnumbered water by 8 to 1. In our solar system, water ice is the main volatile. Comets are often called dirty snowballs because of it. Atlas was a dirty dry ice ball instead. That means it likely formed in an environment rich in carbon and poor in oxygen, perhaps around a carbon star or in a dense molecular cloud far from any sun-like star. The chemistry made Atlas an alien twice over, interstellar by origin and chemical composition. As instruments kept watching, brightness variations appeared on a schedule. Every 4 hours, the light curve rose and fell like a heartbeat. Some nights, a secondary pulse at 2 hours appeared as well. Nature loves cycles, but such precision is rare. The obvious explanation is rotation. If one active vent dominates, its jet brightens when it faces the Sun and dims when it turns away. But Atlas's pattern was too exact. No noise, no drift, no change over weeks of observation. It looked mechanical. A few researchers proposed a binary nucleus, 2 pieces orbiting each other every 4 hours. That could create periodic stress and venting. Others speculated about internal chambers filling and emptying with gas pressure, releasing bursts in rhythm. None of these ideas required technology, but all demanded finely tuned coincidence. When the data showed the same timing across different observatories, coincidence grew thin. By October, Atlas was already on its way out of the inner solar system. We couldn't send a probe to chase it. Yet chance offered a small miracle. 2 spacecraft, ESA's HERO mission and NASA's Europa Clipper, were both scheduled to pass within observation range during late October and early November. HERO, built to study the asteroid Didymos after the DART impact, would sweep past at 8 million kilometers. Europa Clipper, on its long journey to Jupiter, would cross another sector of space close enough to detect Atlas's coma. Neither craft was designed for comets, but both carry cameras and spectrometers sensitive to nickel and carbon compounds. If either detects the same nickel signature, the anomaly becomes fact. If both record nothing unusual, skeptics regain ground. Either way, the window is narrow, only days to gather data before the object fades into interstellar dark again. By mid-October, astronomers had catalogued 15 separate irregularities: the short tail, the sunward jet, the nickel-to-iron inversion, the carbon dioxide dominance, the suppression of water, the 4-hour pulse, the asymmetric coma, jet angles shifting unpredictably, negative light polarization, the early Hubble hints, water emission far from the Sun, the green hue unlinked to known molecules, hydrogen cyanide lines, the sudden appearance of iron emission inside 2.6 astronomical units, and a silence from Mars orbiters that should have photographed the comet but have not released images. Each quirk alone might be noise. Together they sketch an object that refuses to fit. Somewhere in late-night conversations between observatories, someone said the quiet part out loud. What if parts of Atlas were manufactured? Nickel alloys are the backbone of advanced engineering used in turbines, spacecraft hulls, heat shields. They survive temperature extremes, radiation, and corrosion. If a civilization wanted to send something across interstellar space, nickel would be a logical choice. Imagine a nickel-coated structure trapped inside a natural ice body. Over eons, the ice accumulates dust. When it approaches a star, the coating erodes and releases nickel gas. If the surface once used cyanide baths in plating, traces of hydrogen cyanide would appear as well. Directional vents could produce a plume aimed any way they happened to point, even toward the sun. It's speculation, nothing more, but it explains several puzzles at once. It also explains the 4-hour rhythm if internal cavities refill and vent cyclically. The idea spread quietly in side discussions and online forums. No one in academia wanted to attach their name to it yet. On October 3, Atlas passed within 29 million kilometers of Mars, close enough for orbiters to capture high-resolution imagery. The European ExoMars Trace Gas Orbiter, Mars Express, and NASA's Mars Reconnaissance Orbiter all have cameras capable of imaging bright objects in space. None have released a single frame. That silence gnaws at the community. It might be routine data still in calibration pipelines, priorities focused on Martian science. Or it might be something else. Perhaps the images show structures that defy explanation, and teams are verifying before public release. In an age when discoveries reach social media within hours, the absence of data feels like its own message. Between October 11 and 14, solar observatories observed 4 distinct sun-grazing objects plunging into the sun. All came from the same general direction in the sky as Atlas. Sungrazers are common, but 4 in 4 days from one region is rare. They might be fragments of Atlas that broke away earlier. They might be unrelated debris. Without spectra, we can't tell. But if their composition matches Atlas nickel, carbon dioxide, hydrogen cyanide, the link will be undeniable. During the same week, a SpaceX Starship launch video showed a bright point of light near the moon that hung motionless for seconds before vanishing. Likely an optical artifact, yet the timing fed speculation that the sky itself was in upheaval. Scientists prefer coincidences to conspiracies, but patterns have gravity of their own. 3I Atlas is not alone in its strangeness. It follows 2 other interstellar visitors. In 2017 came 1I Oumuamua, a tumbling, cigar-shaped object that showed no tail but accelerated slightly as if pushed by invisible gas. In 2019 came 2I Borisov, a textbook comet, ordinary and comforting. Now in 2025 comes 3I Atlas, which behaves like a comet that read the textbook backward. The pattern is almost narrative. First, an object with no activity where there should be. Second, one perfectly normal. Third, one reversing every rule. Some scientists joke that the universe is teaching in stages: absence, normality, inversion. While comet scientists wrestle with Atlas, cosmologists face their own crisis. The James Webb Space Telescope keeps finding supermassive black holes too large and too early in cosmic history. They exist when the universe was less than 1 billion years old, too soon for normal growth through accretion. To explain them, theorists propose a new class of object: dark stars powered by the annihilation of dark matter rather than fusion. If true, it means black holes came before galaxies, reversing the sequence every textbook once taught. It's a cosmic echo of Atlas, another case where cause and effect invert. Artificial intelligence now reads the heavens alongside us. Neural networks comb petabytes of sky survey data, spotting correlations no human could endure. Trained on thousands of comet observations, They learn patterns of brightness, chemistry, and evolution. When these systems analyze Atlas, they will see relationships invisible to human intuition, links between its heartbeat and its spectral shifts, between jet geometry and nickel abundance. If those patterns hold, the anomaly deepens. If they dissolve under algorithmic scrutiny, we learn something about our bias toward mystery. In the same year, physicists achieve a milestone once thought impossible. They teleport quantum information through 56 kilometers of standard fiber optic cable, the same type that carries ordinary internet data. Quantum states vanish here and reappear there with over 90% fidelity. Information no longer travels, it relocates. Some researchers wonder whether phenomena like Atlas's 4-hour rhythm or reversed jet could involve processes where quantum mechanics and macroscopic matter intertwine. No one suggests teleportation inside a comet, but the principle reminds us that reality still hides layers we have not mapped. February 2025 brings another threshold. At the National Ignition Facility in California, 2.05 megajoules of laser energy produce over 5 megajoules of fusion output. For the first time, ignition is not a fluke but repeatable. Humanity learns to mimic the sun. Energy abundance becomes a question of engineering, not theory. The comparison is irresistible. Fusion rewrites the physics of energy the way Atlas threatens to rewrite the physics of small bodies. Both show that nature permits more than we once imagined. What if anomalies are not noise but messages? What if the universe is more diverse than our categories allow? Atlas violates every rule we teach. So did the first quasars, the first pulsars, the first black holes. Each looked impossible until they became common. Perhaps we are seeing the birth of another category, objects neither comet nor asteroid nor artifact, but something between. As Hera and Europa Clipper approach, their instruments may decide which future we enter. If they confirm the nickel lines and the sunward plume, the textbooks will change. If they find nothing, the mystery will fade but not die. Another will come. There is always another. Because the universe does not repeat itself, it improvises. October 17, 2025. The world of astronomy holds its breath. Atlas continues to climb away from the sun, fading in brightness but not in attention. Every major observatory on Earth now tracks it nightly. Data servers fill with terabytes of raw frames, all focused on a single point of light. Each pixel, a potential clue. Scientists know that waiting is part of the work. Light travels slow compared to curiosity. The data stream from the James Webb Space Telescope takes almost a day to process. Hera and Europa Clipper must perform scheduled calibrations before they can even point sensors outward. Between each stage, the silence stretches. The silence becomes its own kind of gravity. Yet in that quiet, something remarkable happens. Across forums and social media, people who have never looked through a telescope begin to discuss spectroscopy, nickel ratios, radiation pressure. The mystery spreads beyond academia. Atlas becomes a shared question. What is it, and why does it exist? For the first time in decades, the whole world looks up together. To understand why 3I Atlas shakes the scientific world so deeply, we must revisit the story of the first interstellar visitor, 1I Oumuamua. Discovered in October 2017, Oumuamua was a sliver of rock that passed through the inner solar system at 30 km per second. It had no visible tail, no gas, no dust. Yet it accelerated slightly as it left the sun. That acceleration sparked 6 years of debate. Was it hydrogen ice sublimating invisibly? Was it a fragment of nitrogen from an ancient planet? Was it, as some dared suggest, an artificial sail? Each hypothesis explained part of the data and failed at another. By 2023, the consensus was simple but unsatisfying. We do not know. The only fact agreed upon, Oumuamua was the first object confirmed to originate outside our solar system. When 2I Borisov arrived in 2019, behaving like a normal comet, the field relaxed. Nature had balanced itself. But 3I Atlas returned everyone to uncertainty. Oumuamua had no tail when it should. Atlas has a tail pointing in the wrong direction. The first hid its activity. The third flaunts it. Together, they mark the boundaries of our ignorance. Every era of science begins with a contradiction. In the 17th century, the orbit of Mercury refused to match Newton's equations. 2 centuries later, Einstein wrote relativity to fix it. In the 20th, pulsars appeared as radio blips repeating with atomic precision. At first they were called little green men. Later, they became the first proof of neutron stars. 3I Atlas might be our next contradiction. The temptation is to label it quickly, to close the question before it unravels more rules. But the wise response is patience. An anomaly is not an error. It is the universe teaching us the limits of our model. Before leaping to ideas of technology, many scientists explore natural processes that could mimic deliberate engineering. One theory proposes electrostatic acceleration. When sunlight strikes a dusty surface, it creates electric fields that can lift fine particles. On the Moon, such fields make dust hover. If Atlas's surface carried strong magnetic or electric properties due to nickel, charged dust might be ejected sunward, pulled by electromagnetic forces stronger than radiation pressure. No engines needed, only fields. Another idea involves structural collapse. Imagine hollow tunnels within the nucleus filled with pressurized gas. When one side caves in, material could vent through internal cavities oriented toward the sun. Over time, the direction might drift, explaining the jet's changing angle. Both explanations stay within physics as we know it, but neither fits every observation. The nickel-ion imbalance and hydrogen cyanide emission remain troublesome. Nature can imitate design, but sometimes design explains more elegantly than chance. In the early 2000s, the European mission Rosetta orbited comet 67P Churyumov-Gerasimenko for 2 years. During that time it recorded something unexpected: oscillations in the plasma environment converted into audible frequencies. When scientists translated them into sound, the comet seemed to sing. Now, researchers apply the same analysis to Atlas. Using magnetometer data from solar observatories, they transform the plasma wave activity into audio spectrograms. What emerges is a rhythmic pulse every 4 hours, matching the light curve and subharmonics nested within it. The result sounds eerie, a low hum modulated by regular beats, like a slow mechanical respiration. It's almost certainly a natural resonance, but its precision deepens the metaphor. Atlas doesn't only move, it seems to breathe. Around the world, artists, writers, and philosophers pick up the story. For them, Atlas isn't a rock but a mirror. It reflects how humanity reacts when faced with the unknown. Some see it as evidence of life beyond Earth. Some as proof of a living universe where consciousness and matter intertwine. Others see it as another reminder that we overestimate our understanding. Documentaries begin production. University courses update their syllabi mid-semester. Religious scholars debate whether the heavens have introduced a new sign. In talk shows and podcasts, guests argue about motives. If it's artificial, who sent it? If it's natural, why now? The pattern of arrivals Oumuamua, Borisov, Atlas feels almost timed. 7 years apart. Could there be a fourth on the way? AI observatories join the search. Neural networks trained on billions of sky images scan for any motion patterns matching Atlas's trajectory or chemical signature. They comb archives going back decades, searching for faint traces of similar visitors that might have gone unnoticed. A few candidates emerge, weak streaks in old photographic plates that show odd spectral ratios, but none with enough data to confirm origin. Perhaps interstellar objects pass through our system regularly, but most are too dim to see. Atlas is bright only because something active, maybe reactive, burns within it. In response, space agencies propose an automatic Sentinel program, satellites placed at multiple solar orbits using AI to detect and track new interstellar intruders in real time. Atlas might be the last one we ever miss. Back in the laboratory, chemists attempt to recreate Atlas's emissions. They build cryogenic chambers cooled to 50 Kelvin and load them with mixtures of carbon dioxide, water, nickel compounds, and trace hydrogen cyanide. They bombard the samples with ultraviolet light to simulate solar radiation. After hours, they detect faint plumes of nickel vapor forming jets that curve inward toward the light source. Electrostatic attraction between charged particles and the lamp's anode creates a reverse jet, small, but measurable. It is the first laboratory analog of the Atlas phenomenon. Yet the effect is weak. Scaling it up to match 6,000 kilometers requires energy beyond natural levels. Either Atlas contains unusually strong fields, or another process amplifies them. Data analysts at the Max Planck Institute notice something else. When they plot the timing of the 4-hour pulses against minor variations in brightness, the intervals form ratios close to the Fibonacci sequence 1, 1, 2, 3, 5, 8. At first it seems coincidence. Later, statistical tests show the pattern persists beyond chance. Some physical systems, like spiral galaxies and hurricanes, follow Fibonacci geometry because of fluid dynamics and rotation. Perhaps Atlas does too. But others whisper that such mathematical elegance feels intentional. Late in October, an anonymous upload appears on a small research forum. The file claims to be early imaging data from the Mars Reconnaissance Orbiter showing Atlas near Mars. Within hours it spreads across networks. The image, if genuine, shows the nucleus as a metallic ellipsoid with linear ridges, almost like paneling. Resolution is low, authenticity uncertain, but the effect is enough to ignite a storm. NASA declines comment while investigating. Even if false, the leak forces agencies to act. 2 days later, the European Space Agency releases verified images, grainy but real. They show a roughly spheroidal object with one bright reflective patch consistent with metallic composition. Atlas is now confirmed to have areas of high reflectivity, uncommon for comets but not impossible if nickel-rich. The public hears only one word: metal. In universities, philosophers begin framing Atlas as a case study in knowledge itself. For centuries humans have relied on repeatability as proof of truth. Yet interstellar visitors are by definition unique. We cannot experiment on them twice. Each arrival is a one-time revelation. We are forced to build theory from a single data point. Atlas reveals not only new physics but the limits of scientific certainty. News algorithms amplify Atlas. Search trends show millions typing sunward comet, nickel gas, possible probe. Advertising networks detect spikes in telescope sales. Communities form overnight dedicated to tracking every update. Governments take quiet notice, remembering how misinformation once fueled panic over UFO hearings. To prevent chaos, they fund official briefings with measured language. But people prefer wonder to caution. The more officials say we don't know, the more convinced the public becomes that something monumental hides behind the curtain. Then come signals from Hera. The spacecraft spectrometer detects a weak nickel line from the direction of Atlas 5 sigma above background. Telemetry confirms alignment. The data match the ground-based readings almost exactly. Atlas's nickel plume is now confirmed by an independent instrument in space. The finding reaches the public through an ESA press release on October 29. Nickel vapor exists in a jet pointed toward the Sun. The laws of radiation pressure alone cannot account for it. By November 1, 4 main schools of thought dominate. The electrostatic model, surface charge, creates inward jets. The resonant vent model, internal cavities, pulse gas toward the Sun. The magneto-hydrodynamic model, magnetic fields bend ionized particles sunward. And the technological model, Atlas, is not natural but a relic, a probe, or a seed built long ago. The first 3 stay within known physics. The fourth rewrites history. On November 5, Europa Clipper's dust analyzer captures unexpected particles while aligning for a routine test. Analysis shows grains containing nickel, carbon dioxide ice, and traces of complex organics, ethanol, acetone, formaldehyde. The ratios match Atlas's spectrum. Atlas's material reaches far beyond its visible coma, suggesting active ejection rather than passive evaporation. Some models now propose that Atlas emits particles along magnetic lines connecting directly toward the Sun, forming a hidden tether of plasma. When the findings are released, the world reacts in waves. Stock markets barely notice, but cultural networks ignite. Museums announce exhibitions titled Visitors Between the Stars. Musicians compose pieces using the comet's plasma frequencies. Students debate whether they might one day follow Atlas back to its origin. For a brief moment, division softens. The sky belongs to everyone. NASA's Technosignature Group clarifies that Atlas's features are unusual but not proof of technology. Still, they include it as a case study in their next review, the first time a comet joins the same category as radio signals and exoplanet anomalies. Behind closed doors, new intercept missions are planned, small, rapid-response probes able to reach future interstellar objects in months, not years. Atlas, though untouchable now, becomes the reason those missions exist. Astrodynamicists trace Atlas's trajectory backward. The vector points toward the constellation Lyra. Simulations suggest it may have been ejected from a distant red dwarf system 3 million years ago. But its chemistry does not match that origin. Either the estimate is wrong, or Atlas traveled far beyond the local bubble before finding us. Distance ceases to matter. What matters is motion. Something sent it here, by purpose or by chance. Researchers notice a new detail in the nickel-to-iron ratio curve. When plotted logarithmically, the curve oscillates with a period matching the 4-hour light pulse. Each flare changes the ratio slightly, as though Atlas adjusts its composition over time. Some describe it poetically, the comet speaking in chemistry, each element a syllable. Artists translate the data into color sequences and soundscapes. Soon Atlas has its own symphony online, a language of numbers turned to music. In laboratories, engineers replicate the rhythmic venting using electrothermal cycles. They build spheres of frozen carbon dioxide with embedded nickel powder and expose them to alternating heat. The material expands and contracts, venting jets at predictable intervals. Under controlled conditions, the jets reverse direction depending on charge polarity. The phenomenon can exist without intelligence, but intelligence would certainly exploit it. As Atlas fades beyond telescopic reach, humanity looks inward. Every discovery about it reflects something about ourselves. We too are travelers, carrying fragments of origin into the dark. We too emit signals, unsure who listens. Atlas becomes less a mystery to solve and more a mirror of curiosity. It reminded us that mystery itself is a kind of light, soft, steady, endless. And as long as we keep following that light, we remain explorers. By early 2026, 3I Atlas has faded from the night sky. Its brightness fell below the reach of even the largest telescopes. Only the slow data trickle from distant spacecraft still remembers it. Yet the world keeps speaking its name. Atlas has become a ghost orbiting our imagination. At observatories across the globe, scientists return to their routines, but nothing feels ordinary anymore. Every new image is compared to Atlas. Every comet spectrum is checked for nickel. Every pulse in a light curve raises a quiet thought: could it be happening again? In lecture halls, professors describe the event in gentle tones. They remind their students that most revolutions in science begin not with discovery but with confusion. Atlas was confusion shaped like a world. For months it refused to fit any model, forcing humanity to remember that our equations are temporary. While astronomers measure, philosophers write. They call Atlas the question that crossed the sun. To them, the comet represents the boundary between knowing and wondering. They argue that the real meaning of science is not certainty but conversation, the endless dialogue between curiosity and mystery. Their essays spread quietly online, read late at night by people who still look up before sleep. In the archives of the European Space Agency, a young researcher finds forgotten telemetry from Heros magnetometer. When converted into audio frequencies, it reveals a low vibration repeating every 4 hours, faint but persistent. She plays it through headphones and listens to what sounds like a slow breath. For minutes she sits in the dim room, feeling as though the comet itself is alive somewhere beyond reach. She writes in her notebook, "The universe hums, and sometimes we hear it." Meanwhile, humanity changes in subtle ways. Sales of home telescopes double. University enrollment in astronomy rises for the first time in decades. Children who watched the news about Atlas now dream of working for space agencies. The mystery did what few events manage: it replaced fear with fascination. People remember how to wonder again. Museums open exhibitions called Visitors Between the Stars. Inside, holographic projections trace Atlas's impossible tail pointing back toward the sun. Visitors walk through slow streams of light that bend and swirl as if alive. Soft music plays, a recording built from Atlas's plasma tones. Parents lift children to see the projection of the comet drifting through a field of stars. Some children reach out to touch it even though they know it is made of air and photons. In one corner of the exhibit, a small plaque reads, "We never proved what Atlas was. But in searching, we became something new ourselves." Back in laboratories, experiments continue. Chemists recreate fragments of the comet's chemistry, searching for clues in the ratios of nickel and carbon dioxide. They discover small self-organizing structures forming when the mixture is exposed to alternating magnetic fields. Tiny filaments of metal curl and twist, building fragile frameworks that shimmer under the microscope. No one calls it life, yet the movement feels alive. Perhaps Atlas carried the same kind of restless order, a dance between physics and intention. By the middle of 2026, new missions are approved. Sprint-craft-class interceptors are placed in solar orbit, always awake, waiting for the next intruder from the dark. Their motto is engraved on every hull: "We will not miss the next one." The world seems quieter but more prepared. Every telescope, every sensor, every listening dish now waits like a heartbeat stretched across the solar system. Then, on an ordinary night in July, the Sentinel network detects another faint object entering from the direction of Hercules. Its speed matches Atlas's within a few percent. Its inclination mirrors the same path, but mirrored across the ecliptic. The analysts hold their breath. They call it 4-eye Harmonia. Unlike Atlas, Harmonia emits no light at all. It reflects almost nothing, as though covered in the blackest dust. Yet radar pings return clean echoes, sharp and metallic. It is smaller, colder, silent. Within days, headlines call it the second visitor. Sprint Craft 1 launches from lunar orbit 3 days later. It accelerates on a fusion-assisted trajectory that will intercept Harmonia within a year. For the first time in history, humanity will meet an interstellar visitor face-to-face before it leaves. Around the world, people stay up late again, watching the mission clock tick forward. The sky has become a stage and we are finally part of the play. In the quiet between updates, artists paint what they imagine Harmonia to be, a dark twin of Atlas, moving through starlight like a thought between dreams. Writers compose stories linking the two, one bright and rebellious, one hidden and patient. Scientists avoid the myth, yet even they speak of balance. If Atlas was a question, perhaps Harmonia is the answer. Back on Earth, a small radio observatory in Chile detects a series of narrowband pulses near the hydrogen line, one every 8 hours. The timing matches Harmonia's slow rotation. No one calls it communication, but the coincidence is perfect. This time, data flow freely. Every observatory contributes. No secrecy, no silence, only shared curiosity. Months pass. Telemetry whispers across the dark like dew collecting on a window. The stream is steady. Radiation counts. Plasma density. Dust impacts against a tiny plate as soft as snow against a sleeve. Numbers. Always numbers. Each one a footstep through emptiness. In control rooms, the lights are lower now. People speak in half voices, careful not to disturb the shape of the waiting. Coffee cups leave rings like little orbits on printouts. Someone hums without noticing. Someone else sets an alarm for 4 hours later, then another, keeping time with a beat no one can hear and everyone can feel. As Sprintcraft closes the distance, the cameras begin to earn their passage. Pixels sharpen. Edges separate from shadow. The object resolves. It is smooth where rock should be rough. It is consistent where ice should show the memory of fractures and stress. It reflects the infrared like a banked ember and swallows visible light like a lake swallows a stone. Temperature readings arrive in tiny increments. A line that should wobble does not. A system inside must be regulating the heat like a careful hand holding a kettle at exactly the right warmth. A hollow. A chamber. A machine. The world waits. People step out onto porches at night and point at nothing the eye can see. They point anyway. News anchors drop their voices to the soft register used for cathedrals and newborns. Children fall asleep expecting stories where the heroes are patient and the monsters are just questions in disguise. In gift shops, small models appear, Atlas in silver, Harmonia in black. You can turn them gently with a fingertip and imagine that friction is a star. Far from the shelves and living rooms, the real drama happens in the quiet that machines were built to endure. Sprintcraft fires thrusters in a whisper. The probe drifts into a safe holding orbit and opens a bay no one on Earth has touched. A companion the size of a suitcase floats free, orienting itself with a gentle hiss that takes 12 minutes to reach us. A line appears on a monitor. Then an image. Then another. Across that surface runs a pattern that looks accidental until the eye admits the truth. Ridges. Not random. Not weathered. Laid down as if by intention. Spirals following ratios that mathematicians recognize the way sailors recognize currents. The same sequence that once pulsed in Atlas's light curve now lies carved into metal. Fibonacci again. A memory made visible. Spectrometers speak next. Nickel in complex bonds. Carbon in forms that do not fit simple frost. Traces of elements arranged as if a recipe had been followed and then weathered by time. The link to Atlas becomes hard enough to rest a hand upon. Different travelers. One origin. The drone circles toward the terminator, the thin seam where day hands the object back to night. In that grey line, something answers the attention. A flash near the pole. Not a flare. Not a crack. A pulse. Brief. Clean. 3 bursts. Silence. 3 again. The pattern repeats, unhurried, as if the object has all the time in the universe and expects we do too. On Earth, the room grows so quiet the fans sound like weather. Someone checks the clock. Someone else checks the pipeline delays. The intervals are measured twice, then thrice. 4 hours from crest to crest. 4 hours like a tide, like a sleeping breath, like the heartbeat we recorded from Atlas long ago. 2 bodies. 1 rhythm. Whatever they are, they share origin and intention. Messages go out to observatories and universities and small labs where night shift students hold their jackets around their shoulders. People who never thought the sky would write back feel suddenly addressed. Some cry without embarrassment. Some laugh, then cover their mouths, surprised by joy. The pulses stop after an hour. They do not return that day or the next. Sprintcraft holds station and listens. The drone traces every ridge. A map grows around the object the way lichen grows around a stone, slow, faithful, inevitable. We build a model that you can spin on a screen with a fingertip. It is beautiful in the way a tool is beautiful when you do not yet know its purpose. No further signals come. Waiting becomes the work again. Batteries drop. Instruments are powered down, one by one, like lamps at the end of an evening. Before the final switch, flight controllers gather their breath and their notes and say the line they practiced. All systems nominal. Object stable. Mission complete. The transmission leaves as a thought in a thin thread of radio and, minutes later, the craft falls behind the edge of enough. The room does not cheer. It does not need to. A different emotion is present. Completion. Gratitude. The odd tenderness that arrives when a long question has finally sat down beside you, even if it still refuses to answer. In the weeks that follow, nothing explodes. No proclamations end history. What changes is quieter. People write better emails to one another. They pause at windows. Teachers replace a test with a night under the sky. The discovery does not spark panic or worship. It offers proportion. It lets the scale of things back into the room. Projects bloom that no one had budgeted for. Courses appear with names that would have sounded like riddles a decade earlier: interstellar archaeology, magnetoplasma harmonics, quantum resonance in metallic comets. Students sign up in numbers that exhaust the chairs. They learn to draw field lines the way artists draw contour and shade. They argue about whether pattern is speech or simply the scaffolding of nature. A philosopher suggests that curiosity itself is a kind of language, one sender, one receiver, a shared grammar of attention. If so, Atlas and Harmonia may be replies written in mathematics and patience. Museums commission new halls. Visitors walk beneath a ceiling that rotates with the 4-hour cadence. Underfoot, a slow ripple of light moves like a heartbeat traveling across the floor. Some people time their steps with it. Some sit and let the rhythm pass through their breathing until they feel calmer than when they arrived. The audio guide does not shout. It whispers facts and then leaves space for the exhibit to answer. Not everyone agrees on what the objects are. That is good. Disagreement keeps the topic alive. One group argues for a natural resonator formed in a star's debris belt, a kind of self-tuning instrument made of metal and ice. Another group builds models where a civilization long gone used nickel structures to store and bleed heat with exquisite efficiency. A third group says the right frame is not tool or relic at all, but seed packages of rule and rhythm, meant to teach any species that meets them how to hear the universe as harmony. No group wins. The conversation wins. Years accumulate like soft snow. And yet the twins of silence remain close to the surface of daily life. People use the names as metaphors without thinking. A new library takes the name Atlas, a new concert hall takes the name Harmonia. Children who grow up with these words think of exploration as a natural human behavior, like singing or kindness. Scientists keep working because that is what scientists do. The spiral ridges are modeled as waveguides. The nickel mixture is tested for odd superconductivity at unreal temperatures. A lab in Finland accidentally discovers that a certain coil alignment will beat at exactly 4 hours when powered by nothing more than sunlight filtered through thin cloud. The device is set on a windowsill. Researchers eat lunch and listen to their machine breathe. On a clear winter night, a tiny observatory in the Andes detects a single narrowband line near the hydrogen frequency. 3 bursts. Silence. 3 more. The exact cadence. The origin cannot be triangulated before it is gone, but the recording is clean, and the timing is true. The message boards light up. The newspapers do not. It is better this way. The world has learned to protect the fragile. Policy shifts in gentle increments. Budgets arrive for Sentinel probes that can launch within weeks rather than years. Data standards are agreed upon without spectacle. Papers list authors not in the dozens but in the hundreds, names in every alphabet sharing credit with sincerity. Something about the twins makes people generous. And still, there are the small private changes, the ones no graph can hold. Someone calls an old friend. Someone forgives a debt. Someone starts reading to a child every night. Stories where the brave thing is not to conquer but to notice. Where the hero's reward is not a crown but a question worth staying up for. In distant classrooms, students build tabletop versions of the spiral skin with 3D printers and thin copper wire. When they shine a lamp at it from the correct angle, fine dust moves in slow rivers toward the light instead of away. A tiny echo of the sunward jet is born above a lab bench. Hands go up. Eyes widen. A room learns what it feels like for impossible to become demonstration. Theologians write quieter sermons. Skeptics write kinder essays. The center of conversation shifts from proof to posture, from what is it to how do we meet it. Not everything must be solved to be sacred. Not everything must be sacred to be loved. On an anniversary evening, a storyteller sits at a desk and opens a microphone for the sleepy explorer. A single lamp pools light around her notes. Outside, a moth taps the window like a tiny metronome. She does not rush. She lets the first breath belong to the listener. Then she speaks. She tells how Sprintcraft approached in a patience that felt like prayer. How the drone circled. How the ridges turned out to be not scars but sentences. How the pulses arrived like a knock on a door we had been pretending was a wall. She tells how nothing terrible followed, and how beautiful that was. No invasion. No panic. Only a widening of the room we live in. She folds in details that data alone cannot carry. A technician who kept a 4-hour kettle schedule, making tea exactly on the beat. A janitor who paused at the monitor every night and nodded as if the object could see him. A student who taped a small paper spiral to their laptop to remember where wonder begins. The story stretches without strain. It makes space for everyone. Her voice slows the way a tide slows at the top of the beach. She describes the models on bedside tables. She describes the hush in museums. She describes a grandmother who cannot pronounce interstellar archaeology but says it anyway because her granddaughter does and smiles every time. She lets the listener feel the years passing like pages turned carefully so the paper will not tear. Then she lands in the place where endings are not ends. She repeats what we learned without declaring it a lesson. That some questions are not doors to answers. They are rooms we get to live in. That rhythm can be meaning. That patience can be speech. That mystery is not ignorance. It is a landscape. And then, because bedtime is a kind of harbor, she gives the benediction the story has earned. Somewhere beyond the planets, A silver traveler turns on a path that leans toward the stars. Beside it, a darker companion keeps company in the quiet. Between them stretches an ocean of gentle distance where there is no hurry and no waste, only the soft arithmetic of time. Inside that quiet is everything, the pulse of creation, the rhythm of discovery, the heartbeat of curiosity itself. Sleep now, traveler. Let your thoughts drift in long orbits. The mystery is not leaving you. It is keeping watch. Tomorrow, when you open your eyes, we will look up again. And the sky will be exactly as generous as it was tonight. Music rises behind her, barely there, just enough to carry the last lines like a small boat onto a still lake. She waits one extra breath so the listener can set the day down. Then she lowers the fader. The light over the notes goes out. The file saves. Somewhere, a child already sleeping turns on their pillow and smiles without waking. Out beyond Neptune, the twins continue as they were made to continue, one bright in warmth you cannot see, one dark in light you cannot measure. No alarms. No schedules. Just 4 hours between pulses that may never come again and do not need to. Because the message has been delivered. Because the message was never a sentence at all. It was a way of listening. And as long as humanity keeps that cadence even imperfectly, even forgetfully, even with coffee rings on the printouts, we belong to the conversation. We are not alone. We are attentive. We are, at last, explorers who remember to rest. Good night.